Hello everyone, and welcome to this video tutorial. In today's tutorial, we are going to talk about vertical motion under gravity. So what is vertical motion under gravity? What are the concepts involved in this vertical motion under gravity? Let's first of all deal with the concept of vertical motion. Vertical motion is a special type of linear motion. What makes it special is that it's a kind of motion that takes place in the air, whereas other kinds of linear motion may take place on a flat surface, such as the top of a table or the street. Again, since this kind of motion takes place in the air, bodies undergoing vertical motion have a special kind of acceleration, which is called acceleration due to gravity. This acceleration due to gravity has a constant value of 10 meters per second squared. An acceleration of 10 meters per second squared means that any body undergoing vertical motion will change its velocity by 10 meters per second every second throughout its motion. Having understood this, let's really look at how to describe vertical motion under gravity. In describing vertical motion under gravity, we use Newton's equations for uniformly accelerated motion. In our previous video, we covered Newton's equations for uniformly accelerated motion, so you can check that video out. The link is in the comment section as well as the description for you. So Newton's equations of uniformly accelerated motion are basically three. We have 1. V is equal to u plus at. 2. V squared equal to u squared plus 2as. And 3. S is equal to ut plus half at squared. The V stands for the final velocity of the body. The U stands for the initial velocity of the body. The A stands for the acceleration of the body. And the T stands for the time taken to undergo the motion. And the S stands for the displacement or the distance traveled in the course of the motion. In vertical motion under gravity, we are going to modify these equations a little bit to suit this particular concept. But before we get to that, let's consider the two main cases under vertical motion under gravity. Number 1, when a body is dropped or released from a height. Or number 2, when a body is projected or thrown vertically upwards. Both of them constitute vertical motion under gravity. Let's take the first one. When a body is dropped from a height, it moves towards the center of the earth by the influence of gravity. I want to add here that in this tutorial, we are considering only the ideal cases where the only influence on the motion of the body is gravity, which means that other factors such as air resistance is considered negligible. In this case, the equations of motion for a body dropped or released from a height are: number 1, V is equal to u plus gt. Number 2, V squared equal to u squared plus 2gh. And number 3, h equal to ut plus half gt squared. So if you compare these equations with the normal equations of motion that we have, you would realize that some new symbols have been introduced. We have replaced the S with the H, where the H stands for the height from which the body is dropped. And we have also replaced the A with the g, which specifically refers to the acceleration due to gravity. Still under the first case, let's explore some more ideas. If a body is dropped from a height, it will take some time before it will hit the ground. How long will it take a body being released from a height to reach the ground? We know that a body will be at rest just before it is dropped or released from a height. Consider a coconut hanging on a coconut tree, for example. While it is hanging at that height, it has no velocity, and so its initial velocity u is 0 meters per second. With this first case, we can derive a relation for the time t taken for the body to hit the ground. In doing so, we consider the first equation, which is v is equal to u plus gt. Since u is 0 meters per second, the equation is now going to be v is equal to gt. And by making t the subject, we have t is equal to v over g. Now let's consider the second case, which deals with when a body is projected or thrown vertically upward. When a body is thrown vertically upward, its motion is in the opposite direction of gravity. This means that the object moves against gravity. Therefore, the value of acceleration due to gravity, which is 10 meters per second squared, would have to be negated because they are moving in opposite directions. The equations of motion for this case now become 1. V is equal to u minus gt. 2. V squared is equal to u squared minus 2gh. And 3. H is equal to ut minus half gt squared. Alright, let's consider two concepts under this second case. So let's take the first one. That is the time taken for the body to reach its maximum height. When an object is thrown vertically upwards, it moves with an initial velocity, u. Since it moves against gravity, its velocity will be decreasing by 10 meters per second each second. This means that eventually its velocity will be 0. When a body reaches its maximum height, its velocity is 0 meters per second, and this is its final velocity, v. So using the first equation, which is v is equal to u minus gt, we can write that 0 is equal to u minus gt, because at the maximum height, the final velocity v is equal to 0. We are going to get gt is equal to u, and by making t the subject, we have u divided by g. So the time taken to reach the maximum height is the initial velocity divided by the acceleration due to gravity. In addition to this, we agree that the body, when projected vertically upwards, will not stay in the sky. It will have to fall back vertically to the ground. Since its acceleration is constant, it will take the same time to hit the ground just as it went up to reach the maximum height. So the time taken to move up and down to the ground will be given by t is equal to 2u divided by g. That is multiplying the time taken to reach the maximum height by 2. Now let's look at the second concept, which is the maximum height the body can reach. When a body is projected vertically upwards, it will move to a point where it cannot move any longer, because its velocity will be decreasing as it moves up until it becomes 0, and then it will fall back. Depending on the initial velocity it was given, it can reach different maximum heights. We already know that at the maximum height, the final velocity is 0. And since we want to find the maximum height, which is h, we have to use the second equation, which is v squared is equal to u squared minus 2gh. So when we put v equal to 0, we are going to have 0 squared is equal to u squared minus 2gh. Then we can have 2gh is equal to u squared. Finally, the maximum height will be equal to u squared divided by 2g. Alright, at this point in this video, we have discussed the two main cases for vertical motion under gravity. But before we solve a few problems, let me introduce you to a special case. For this special case, we will consider a situation whereby the body is not projected vertically upwards from the ground, but from a point above the ground. In order for us to analyze the motion of such a body, let's consider this free body diagram. From the free body diagram, we see that the height above the ground is labeled x, and the maximum height the body can reach from that point is labeled h max. And so for us to find the total height the body can reach from the ground to that maximum height, we have to add the x and the h max. And from the diagram, adding the x and the h max will give you the capital H, which is the total height the body can reach from the ground. And so the total height, capital H, will be given by x plus u squared divided by 2g. So in the question, you may be given the value for the x, and you can use it to do your computations. What about the time taken for the body to hit the ground? To find the time taken for the body to hit the ground from that height or point, we first find the time taken to reach the maximum height from that point as t1, and that is given as t1 is equal to u over g. That is when the body is projected vertically upwards. After that, we have to find the time taken to move from that maximum height to the ground as t2. Here we have to be fast to observe that as it falls back, the final velocity at the maximum height, which is equal to 0, will become the initial velocity as the body falls back to the ground. And so the final velocity is equal to the initial velocity, and both of them are 0 meters per second. So from h is equal to ut plus half gt squared, we can write that capital H is equal to 0 plus half gt squared, because the u is 0. So 0 multiplied by t is 0. And so we are going to have h is equal to half gt squared as the maximum height it can reach from the ground. If we make t the subject, we are going to get t is equal to square root of 2h over g, and this is our t2. So the total time taken for the body to move up and return to the ground will be equal to t1 plus t2. Having gone through, at this point, we have gone through all the necessary cases and concepts for vertical motion under gravity. So let's solve some problems. Our first problem: a stone is projected up from the ground with a velocity of 90 meters per second. calculate the time it takes to travel up and back to the ground. We have been given that acceleration due to gravity G is 10 meters per second squared. So how do we solve this question? First of all, we all have to observe that the stone is projected up from the ground. Hence, its acceleration due to gravity must be negated. In the question, we have been asked to find the time taken to travel up and back to the ground. We just found that the time taken in this case is given as T total is equal to 2U divided by G. And so the total time is equal to 2 multiplied by 90 meters per second divided by 10 meters per second squared. And this gives us 18 seconds. So it takes the body 18 seconds to move up and to come down to the ground. Now let's take our second question. A body is projected vertically upwards with a speed of 10 meters per second from a point 2 meters above the ground. Calculate the total time taken for the body to reach the ground. Acceleration due to gravity has been given again as 10 meters per second squared. This question needs attention. And so let's first of all draw a free body diagram to analyze it. And this is our free body diagram. From the question, the body is being projected vertically upwards from a height 2 meters from the ground, and it will reach a maximum height before returning to the ground. And so the 2 meters plus the maximum height it can reach from that height is the capital H. This particular situation combines both upward and downward motion under gravity. So we have to find two times, that is the T1 and the T2. T1 representing the time it takes to reach the maximum height projected from the 2 meter point, and then the T2 is the time taken to move from the maximum height to reach the ground, and then add them. So for the vertically upward movement, we know that T1 will be equal to U over G, and this gives us T1 is equal to 10 meters per second divided by 10 meters per second squared, and the T1 is 1 second. So it takes the body 1 second to move from that height to the maximum height. For the vertically downward motion, we know that T2 is equal to square root of 2h divided by G. Now we know the capital H is equal to the maximum height plus the 2 meter height. When the body moves vertically upward, we know that the maximum height reached is given by H max equal to U squared over 2G. So let's substitute the values. We are going to get 10 meters per second all squared divided by 2 times 10 meters per second squared. And when this is computed, we are going to get 5 meters. So the total height from the ground to the maximum height is 5 meters plus 2 meters, giving us 7 meters. So with this, we can find our second time, the T2. So the T2 will be equal to square root of 2 times 7 meters divided by 10 meters per second squared. T2 will give us square root of 14 meters divided by 10 meters per second. And finally, T2 will be equal to 1.18 seconds. So the total time taken will now be equal to T1 plus T2. And this gives us 1 second plus 1.18 seconds. And the total time is 2.18 seconds. Now let's take our last question for this tutorial. It reads, a stone is thrown vertically upwards with an initial velocity of 40 meters per second from the top of a hill of height 22 meters. Calculate the distance traveled by the stone from that height to the ground. So we realize that this is a similar question to the second one we just took. So let's draw our free body diagram to analyze the motion. From the question, the body is projected from the top of a hill and the hill is 22 meters high. So from the top of the hill, the body will reach a maximum height, h max. Here, we are told to calculate the total distance traveled by the stone from that height to the ground. So in simple terms, we can calculate the distance covered from moving up and down to the hill and then add 22 meters to our answer, which will take us to the ground. For vertically upward motion, the distance traveled can be expressed as v squared is equal to u squared minus 2gh. When we make h the subject, h is equal to u squared minus v squared over 2g. We know that at the maximum height, the v is equal to 0 meters per second. So h is going to give us 40 meters per second all squared divided by 2 times 10 meters per second squared. H gives us 80 meters. And this is the same as the distance it will cover as it comes back from the maximum height to the top of the hill. And so the total distance that the body can cover from the point where it was projected upwards, coming back to the point and then falling to the ground, it gives us 80 meters plus 80 meters plus 22 meters, and that is 182 meters. Thank you very much for sticking with us to the end of this video tutorial. We hope you have enjoyed studying with us. Therefore, subscribe to our channel, like the videos, and share with your friends. Thank you so much for your time.